Okay, welcome back from break. We're continuing our study of writing equations. So in our math interactive notebook, our TOC for today is going to be writing multi-step equations. So we talked previously, we made lists about words that meant addition, subtraction, multiplication, division, exponents, grouping, equality, all of that. Now we're moving on to the next step. We're moving to the next level of writing multi-step equations versus just writing a single or two-step equation. So again, writing multi-step equations, I'm on page 35 in my notebook. You may be on a different page, depending on how big you write, etc. So make sure you write that in your TOC, and we're moving on in 30 seconds to start taking the notes. So I'm going to go ahead and turn to page 35. Top, I'm going to write writing multi-step equations. Now, writing equations is very nuanced, right? Because you're not always going to see the exact same words that mean addition or subtraction, etc. So we like to employ something to help us really with our problem solving. We call that method fuse. Okay, so we're going to be talking about the fuse method. And this is kind of something that you should see like kind of throughout our school, just kind of a helping hand in helping you set up your problems. As we go through and later on in this unit, we'll talk about the box method, etc. We're going to actually employ boxes here, but there's actually like a box or table method that we're going to use later on as well. So what does fuse stand for? So F is a reminder to find the important numbers and or words, okay, in the problem. So you may want to underline them, highlight them, whatever, circle them. Sometimes I underline numbers and circle things I think are going to lead to symbols. That's really like a personal preference. The second is U. And U stands for understand what is being asked. So you want to make sure you know what they're asking you to locate. A lot of times in a problem, there's information that you don't need in order to solve the problem. Or sometimes you need to solve for one piece of information in order to get to the answer that you're ultimately need for your final answer or what's being asked of you. S. Select a strategy to use to generate the answer. And we say select a strategy because you can use fuse for problem solving in general. We're using it specifically for writing equations. So our strategy is going to be to write the equation. And within that strategy, we're going to use kind of a bigger box method to help us organize our work. And lastly, we have evaluate your work. And, ultimately, you're going back to, are you answering the question that's being asked of you? Have you found the right piece of information? So kind of how is that going to apply to this larger box of organization that we're going to do? So first we have the task. Make kind of like we're going to use the rest of the paper to make our box here. Let's see if I can get this just a little bit closer here. Right? So the task. We need to know the question to be answered. We need to define the variable. We're going to need to write the equation. We're going to need to solve the equation or equations. And we say that because right now we're learning how to write one multi-step equation. But in our next unit of study, when we cover systems, we're going to learn how to write multiple multi-step equations and how to solve them together. So we're going to need to solve it. And then, as we know, we need a solution sentence. Thena, shh. It's my dog, Thena. We'll take a quick pause and let her outside. So make sure you get that all written down. Real life happening right here where your dog interrupts your video and you got to let him out. Okay, so that's our larger box method. And how does fuse and this box play out? Well, we're going to put F here because within the task or the question is where we're going to identify those important numbers and or words. Here is our U. The question we answered, we're going to find that in our ability to understand what's being asked of us. Defining the variable, we're going to also pull from the task. It's going to help us identify what don't we know. Our strategy is to write an equation. And evaluate is going to occur when we solve it and when we write our solution sentence. Okay, so give you a minute there, and then we're going to move on. And we're going to work through a task together to make sure that we're all on the same page and that you guys understand. So in your digital math interactive notebook, we've provided 2 GPs that you need to do today. And we've also, there's also a separate activity. So we're going to go over the GPs and get some practice there. So we'll see here and here is the same thing, right? This is the question, and that is essentially our task. So a bookstore sold 18,000 paperbacks one month. These are actual books in case you guys are digital readers like me. This was 10% less, I'm going to underline 18,000, than the number of paperback books the store sold the previous month. Write an equation where P represents the variable or the paperbacks sold in the previous month. How many paperbacks did the store sell in both months combined? Okay. So, question to be answered. Total paperbacks sold for the previous 2 months or 2 months. We're going to define the variable. They actually did this for us. They told us P is going to equal the number of paperbacks sold last month or the previous month. So what do I know? I know that in this month, it's 10% less than last month. Okay. So how could I get to that? Well, I know there's some number from last month. And if I subtract this month's sales, that should give me 10% of last month, right? Or of P. So I can use that as my equation. So P minus 18,000. And now I need to put 10% into a usable math term. So I would take 10 and I would divide it by 100 to make it a decimal. I'd get 0.1 or 0.10. So 0.10 P, like I know that's what's equal to. So I'm going to bring that over here and I'm going to solve it. So here I'm going to just use my 5 steps for solving equations. I don't have any distribution. I don't have any combination because there's only one place where I have 2 terms and they're not alike. So now I'm going on to rewind. So I need to get all of my P's on one side. So because this P is already isolated, I'm going to move this P over here. So I'm going to minus 1 P from both sides to get negative 18,000 equals negative 0.9 or 0.90 P, right? Because 0.10 or 1/10 taken from a whole is going to give me 9/10 left. Then to undo this, I'm going to have to divide both sides by 0.9 or negative 0.90, right? And I don't really need the 0. I'm just leaving it there just to help us understand when we subtract from 1 what happens there. So the negatives will cancel out. And as we know, when we're dividing by we're actually, I guess, yeah, dividing by 0.9. We wind up with $20,000. Okay, so now we have our answer. We make sure P is equal to the number of paperbacks sold last month. But is that what I'm looking for? They want me to actually do the total of paperbacks sold for the previous 2 months together. That's what I'm actually looking for. So I needed this information to be able to do what I'm going to do next. So last month they sold 20,000, and this month I know they sold 18,000. So together they sold 38,000 books. So the solution sentence: the bookstore sold a total of 38,000 paperbacks over the 2 months. Leave you a minute to make sure you have that all down. Maybe jot down questions if you don't understand so that when we meet online tomorrow, we can answer those for you. Okay, so moving on, let's look at the next GP problem that you're given. Hopefully we'll have a little less dog barking during this. So our task, Marlo needs to cut 3 bookshelves, right? And I'm going to circle the 3, from a board that is 1.8 meters long. The second shelf, Athena, is 15 centimeters longer than twice the first. Oh, dog issues, dog issues. 1 second. Yeah, I think there's a wild turkey walking in the backyard. The people behind me. That's where all the barking's coming from. And the remaining shelf is 5 centimeters longer than the first shelf. What's the length in meters of the first shelf? Right? So question to be answered. Length of first shelf. Define the variable. Well, we need to find that first shelf. So we're just going to make it n. I don't like working with s's. They look too much like 5s. So n is length of first shelf. But there's 3 shelves here, and I just know the total for all of them. So I'm going to go ahead and just write for the second shelf. The second shelf is 15 centimeters longer than twice the length of the first. So twice the length would be 2n, and 15 longer is 15. That's the second shelf. And then the third shelf, the remaining shelf, right? Because there's 3 shelves up here. The remaining shelf is 5 centimeters longer. So longer is going to mean to add than the first shelf. Here's something else I noticed though. One of the things up here is 1.8 meters long, and these are talking about centimeters. Those aren't the same units of measurement. So I need to know cent, right? Cents. There's 100 pennies in $1, which means that the relationship between centimeters and meters is 100. So to convert 1.8 meters, I'm going to have to multiply that by 100, and that gives me 180 centimeters. Now, the answer needs to be in meters. I'm going to convert back, but usually it's easier to go bigger rather than go smaller because that would create really tiny decimals that I'd work with in the equation. But I know that this is the total, right? So whenever I'm looking for a total of something, that means add. So I need to add the lengths of each shelf together to get the total. So first shelf is n. Second shelf is 2n plus 15. And the third shelf was n plus 5. And together, that should give me 180 centimeters. So n plus, I'm not going to go put those parentheses in again because there's nothing outside of them except the number 1. So I don't really need them. So distribute, I don't have any grouping symbols left. Combination, n, 2n, and n together give me 4n. 15 and 5 give me 20. So after I've done that combination, I really break this down to a 2-step equation. So now I'm in the rewind step. And again, my goal is to solve here. So I want to isolate this term first. So I'm going to rewind a positive 20 or adding 20 by subtracting or adding a negative 20 to both sides. So that's going to cancel out, and I'm going to have 4n left, and 180 minus 20 is 160. Then to get n, I need to get rid of 4. These are multiplying, so I'm going to use my multiplicative inverse and multiply by 1/4. 4 goes into 16 4 times, and 4 goes into 0 times. So n equals 40. So what have I found here? If I go back up here, I can see I've just found the length of the first shelf. Do I need anything else? I don't, but I have to put it in meters. Remember, this is 40 centimeters. So to go to centimeters, I multiply by 100. To go backwards, I'm going to divide by 100. So 40 divided by 100 is going to be 4/10. In other words, 0.4 meters. And it's okay that I use a decimal here because I'm talking about a unit rate of measurement. You know how I love fractions, but unit rates of measurement, money, that's okay to use decimals. So what is the length in meters of the first shelf? Mario, because remember, I want to talk about who, what, when, where when I write my sentence. Mario needs to make the first shelf 0.4 meters in length. Okay. So that's kind of how we use the box method to do this. And your activity today consists of additional problems in this box method. And that's it. That's how we write multi-step equations, or our first method for writing multi-step equations.